Okay, so a boy throws a pebble vertically upwards, okay, with initial speed of, 14.7 meters per second. Okay, so we'll take upwards as positive because that's the direction the pebble first moves in, upwards. Of course, then acceleration is acting downwards, all right? So 9.8 downwards. So when we use our equations, okay, in part A, it's what to say, calculate the speed of the pebble 2 seconds after it's been thrown, while u is 14.7, isn't it? Okay, the initial speed. Acceleration then will be minus 9.8, of course, right? Because we've taken upwards as positive, the direction it initially goes in. Acceleration, of course, acts downwards, so it's opposing the positive direction, so minus 9.8. And they want when t is 2, so we want the speed. So using v equals u plus at, v will equal to u, which is 14.7, a is minus 9.8, and t is 2. So if I work that out on my calculator, comes out to be minus 4.99. Now that's okay, because remember velocity, not only gives us the speed, but it also gives us direction as well. The fact that it's coming out as a negative means that it's opposing the positive direction. So velocity there is telling us the direction it's going in. So because it's minus, we're actually going downwards. Okay, so when t is 2, the pebble is actually falling. All right, which is going to happen, isn't it? Because it's projected upwards to start with. It's only going to rise for so much time, and then it's going to hit its max height, and then it's going to fall. Okay, and after 2 seconds, it's already falling according to this. But when it says then its speed, when it asks for its speed, we need to say that speed is 4.9 meters per second. So you need to make sure you put speed as positive because it's the actual size of it, right? How fast it's going. But the fact it's minus says that it's actually going downwards. Okay, so part B then, calculate the speed of the pebble when it hits the ground at the foot of the cliff. So, because we know that the height of the cliff is 70.2, that's going to come in use here because when it hits the ground, okay, the displacement then it's going to have something to do with this. But because we're going to be down here, and remember displacement is 0 here, okay, where it starts, upwards is positive, downwards is negative, so displacement is going to be minus 70.2. Okay, in that case there. We know the initial speed is 14.7, we know A is minus 9.8, and we want v, don't we? We want the speed. So we can use there v squared equals u squared plus 2as. So v squared will be 14.7 squared plus 2 times minus 9.8 times s. And of course it's so important to have s there as minus, isn't it? 70.2. Okay, because it is negative displacement. In terms of our axis system here, upwards is positive from our origin here, and then downwards negative. So type that into my calculator. And we get 1592.01. Okay. So to get v then we need to square root that answer, and we get 39.9 meters per second. Okay. Part C then says, for how long is the pebble at least 3.969 meters above the top of the cliff? Okay, so basically at the start it goes upwards and it rises, okay, and then it gets to its max height and then it falls. So how long is it above 3.969? So what we need to do is set the displacement to equal to that, right? So let's look at when s is 3.6, what is it, 3.969, get these numbers the right way around. 3.969, that's right. So again, we know U is 14.7, we know A is minus 9.8. So we want the time, okay? We want to work out the time. Now, essentially, if you think about this here, okay, at the top of the cliff here, the pebble, initial velocity takes off at 14.7, okay, and then it will rise, and it'll, maybe that's the height there, 3.969, and then it'll rise to its max height, then it'll fall again. So we want the time that it takes to get from here all the way up and then all the way down again. So how long is it basically in this period here above 3.969? So if you think about it, we can get 2 times out when it's equal to 3.969. So we can get the time when it equals to 3.969 on its journey up and then 3.969 on its journey down. We can see the difference between those 2 times then to work out how long it's above 3.969. So using S equals ut plus half at squared. Okay, so S is 3.969, U is 14.7, T minus then 4.9 T squared, because half A is half of minus 9.8. So we've got ourselves then a quadratic equation. Okay. If we get everything onto one side, it doesn't look very nice quadratic, to be honest, like this. Okay. So what I'm tempted to do here is just use the formula method. Okay, so the formula method would be minus b plus or minus square root b squared minus 4ac all over 2a. That's what t would equal to. So if we put the times in there, so b is minus 14.7, yeah.